Hello everyone. Welcome to the solution of LeetCode problem 665 named non-decreasing array. In this problem, we are given an integer array of n integers and our task is to check if it could become non-decreasing or increasing by modifying at most one element. Suppose in the first example, the array contains three elements, which is 4, 2, and 3. Now, if we modify the element 4 with 1, then the array will become 1, 2, and 3. So here we have to return true because 1, 2, and 3 are non-decreasing or increasing. But in the second example, the array is entirely decreasing, which is 4, 2, 1. So here it is not possible to make this decreasing array non-decreasing by modifying at most one element. So here we have to return false. Now the constraint are the array length can be in between 1 to 10 to the power 4, and each of the array element can be in between minus 10 to the power 5 to positive 10 to the power 5. I hope you understood the description. Now let's move on to the algorithm. Now, to understand the algorithm, we have taken an array. The array contains three elements, which is 3, 5, and 4. Now, we have to iterate each of the elements from left to right and check some of the conditions. So what is the condition we're gonna check? At first, we have to check whether our current value is less than our previous value or not. Because if our current value is less than our previous value, that means in these positions, the array become decreasing. So here we can see that our current value is suppose 4 and our previous value is 5. So here 4 is less than 5. So we can say that in these positions, we have to make one operations. So what if we make this element 5, 4, or make this array 3, 4, and 4. Now here, if currently we are presented in this last position, suppose it is I, if we currently presented here, then we can modify the previous element of this I. That means we can make the operation such that a of I minus 1 is equal to a of I. So this is one possible scenarios. In these positions or in this case, we will definitely modify the middle element with the next element behind it. Now, there can be scenarios such that the array look like something like this, which is 3, 5, and 2. Now here, in this case also, the element 2, which is less than the element 5. That means here, the array is decreasing. So we have to make one operations here. So the optimal strategy is to make this last element to 5. So if we make this element 5, the array will become 3, 5, and 5. So here the operation is a of I is equal to a of I minus 1. Now we are examining this algorithm by using the small test case. So it can be possible that our input may have many elements, right? So if our inputs has many elements, we have to run a loop from left to right, and we have to make this kind of operations and find this kind of pattern. At first, we have to check whether the current element is less than the previous element or not. If our current element is less than previous element, then we have to make two checks. whether it can be possible that the current element is greater than the previous two element, or the current element is greater than the previous two element. That means it can be possible that current element 2 is less than the previous two element, which is 3, or the current element 4 is greater than the previous two element, which is 3. So here we will find two of the cases. That means if our current element is greater than the previous two element, that means we have to change the middle element with the current element, right? Which is a of I minus 1 is equal to a of I. Or there can be possibility that our current element 2 is less than the previous two element. In this case, we have to replace our current element with the previous element, which is a of I is equal to a of I minus 1. After making this, the resultant array will become non-decreasing or increasing. So we have to check these combinations after iterating each of the value, and we have to make these operations exactly 1 times. So suppose we make these operations here 1 times, and in these positions we have found another pattern here. So in this case we have to return false. So we have to keep track the number of operations we are performing. And if in any of the positions our number of operations is greater than 1, then we have to return false. Otherwise, we have to return true. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named check possibility. The parameter of this function is a vector. And if the vector size is 1, that means it is already sorted. Otherwise, we have to take a count value and run a loop from 1 to the size of the array. Now, if our current element is less than previous element, that means we have to make one operation here. That means we have to upgrade the counter value. So now if the counter value is greater than 1, we have to return false. Otherwise, we have to check two patterns. Whether it is possible that the current element is greater than is equal to the previous two element. In this case, we have to make a of I minus 1 to a of I. Otherwise, a of I is equal to a of I minus 1. After that, we have to return true. I hope you understood the algorithm and the code. Now let's move on to the time and space complexity analysis. In this program, the time complexity is big O of n because we are iterating each of the element on the array, and the space complexity is big O of 1 because we are using constant extra spaces to solve this problem. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.